Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Thanks, Evelyn and Microsoft, for organizing this wonderful event of the interactive workshop. The program is so far so good. The talk this morning, and especially the demos in the lunch, I was only able to look at 2 demos. I hope I have the time to look at more after in the break. So I want to share our result in building this new type of search for finding fine-grained or object on the web. I will be giving a demo-driven. I like to see the demo in the lunch. So I want this to be a demo-driven talk, and feel free to interrupt anytime. And I will be using your names. I volunteer your name to do the demo, so I hope you don't mind. I'm using your name for one, because you are famous, okay? Second, because they show some of the points that can see the strength and the weakness of the system. So this is definitely not my own work. I'm just the PR. A lot of students, including Tao Chen, he's the really main builder of the whole system here. So I'm glad to have him here. So I want to start with saying hello to all of you. I think we did some demographic survey this morning. This is very international. I'm from Taiwan. In Taiwan, I grew up hearing my parents, the way they greet their neighbors. The first thing in the morning is very strange. They would ask, have you eaten already? I think this is very, too food-oriented. So when I was going to become, coming to U.S., become a graduate student, I did have time to adjust to the culture here. I never really understand what my advisor means when he say, how are things going? Okay. And then, when I was going to become a professor, I consulted my advisor. What should I learn to look more like a scholar? He told me that you start with the first thing you tell people. You have to ask things that are right. What have you been reading lately? Okay, to show that we are, literally intelligent. Okay, but now I figure out that as all of you might have the same feeling here, we are gradually moving into a different world. We don't greet with this. We now greet, what have you been searching lately? Okay. A question I want you to think about that. Let's take 2 seconds just to pause. I'm sure you are not going to share this, with me. But believe me or not, if you have not done a search on Microsoft or Google today, then you have not lived your day. Okay. So make sure that you do that before you go to bed. So what have you been searching lately? Many times that we are searching for documents, pages. Yes. But many other times, we are not really looking for pages to read. Okay, we are just forced to read all these pages. But because we are looking actually more fine-grained information or entity or object. So you may be thinking that, why in the hell is that Kevin Chen on the stage? What has he been doing? Where is he from? You may want to search that. You might be looking for my homepage or university area. Okay, Max Neal is our department head. I got to, greet him once in a while. Okay, so what's his email number? Okay, so how about the customer service phone number of Amazon? Okay, so you may want to know about what professors are actually doing database at EYUC, because you want to send an email, tell them that you are applying for the program and you are very interested in their area, whatever they work on. Okay, you may be, you are a graduate student, some of you are. Next week there is this seminar coming up. Your advisor told you that, pick one good paper from maybe say Sigma, and then present that. Because your school is in the middle of nowhere, it's hard for you to get external speaker. So then you think about that, this weekend you are going to be busy. So how about let me look for on the web? It's easy for paper to be online, but how about the PowerPoint? If I can find a pair of that, I can read paper, and better yet, I can present from the author's perspective. It's always the most authoritative and most time-saving. Okay. How about the date of Sigma 2008? Okay, and so on and so on. So I want to show you that all this can be done by a general framework, what we call entity search. So to begin with, I think we have to think about. People say that the one revolution in computer science is this philosophy of we see weak. What you see is what you get. But in search, I think we have been very nice to all the big names in search, are we actually searching for what we want? In other words, is that what we are searching is what we really want? Okay. Or are we just trying to get into, whatever the engines provide us? So I have this picture. I think that, this whole web is the wealth that's shared by all the human beings of our society. It's by far the ultimate database, knowledge base, whatever you call that. However, we only have very limited window to look into this world. No matter what you are thinking, you may be thinking about some date, the due date of Sigma, or some phone number, or some email. But you try to formulate your keywords. You may just say Kevin Chen. You don't say Kevin Chen phone. You know that this may not always give you the best page, because phone may just be spelled out, as the 123, -457. It doesn't say PHONE. In any case, you get as the result, a ranked list of pages. You may be lucky to get the home page in the first one, and then you click on that. Okay, maybe you are sure, maybe you are not. You look into the next result, and so on, and so on. Okay, so really, we have our specific information in mind, but we are really only looking for pages. In other words, the World Wide Web is now served as a library, and the engines are librarians. They give us reference into documents. I would argue that what we are living is in a modern shopping mall. It's a department store. It's all kinds of different objects. Library is just one section of this shopping mall. So to begin with, I want to see what kind of conceptual view we put on this notion of the web, so that we will provide the function accordingly. So many people, many engines, many researchers, I started my graduate study in '93. I think we have gone through all these different generations. It's surprising to see how fast, how rapidly this domain evolved. And we could say that people are trying to perceive this big animal. In computer science, we are supposed to be handling artifacts. We are supposed to create, good stuff. But now this web is become like a natural phenomenon that we don't really understand that. Perhaps we are just seeing part of that. That's why I think that there is an evolution of how we look at this corpus of pages. So in the very beginning, people look at it as a collection of pages. That was the first generation that I skipped here, Alta Vista, or to me, maybe InfoSeek. They were all belonging to that. Then the second generation came along. The real innovation there is to think about that as not just the traditional collection of document view, but rather it has structure. This corpus has structure of this link graph. I think the audience in this room actually contributed to the creation of that era of thought, created this second generation of search engines. So the conceptual view of this graph actually created a new enhanced function about this search. Then what I want to think here is that because the web is now become the ultimate place of our virtual life, it's really not just document. So we would like to take an entity view of the web. So instead of just documents are now just containers. Okay? They contain entities of all sorts. You may find a PDF file, online papers, or PowerPoint, online presentation from authors, or a date, or email, or a phone number, or whatever you want to find out. Okay. So do we have technology? Do we have a framework to find out this more fine-grained information entity? So you ask me what is entity. I don't want to hint on you that this necessarily means the kind of entity in entity extraction in the IE field, information extraction. It could be something like that like person name, location. These are, you have to apply statistical method to extract them. But in general, it's just something you can recognize. Okay, it could be phone number. You recognize that by pattern. Email address or PowerPoint, you simply recognize by the type of the object, or images, or person name, or book title, author, price, and so on. Okay, so here this view is not unsupported. Several earlier work, or in this era, okay, in the past couple years, starting from very early, like in 1998, when I was still a graduate student at Stanford, I saw this demo, which kind of hit me. They put professor's name, like Kevin Chen, with some area like artificial intelligence. They throw this to Google. They found it has 0 hit. They concluded that Kevin Chen doesn't know about AI. They threw maybe database into that. They found some hits. They conclude that it may be more possible that Kevin Chen will be doing, AI or database. Okay. So here, they will try to find out the fine-grained information about research area by this global hit count. Okay. The BE engine built in Seattle here, or known as the know-it-all system, also apply this global hit count. Okay. And then how about using local proximity patterns? I think we are using that every day. Now, if you are preparing your presentation, you definitely will be looking at the Google web page search to find out images, cute photos, to add on to decorate your talk. So we do image search. There is no image analysis technique involved at all. It's just using keyword in the context. So we are using a local pattern, such as if you are looking for, keyword is Microsoft, maybe the output will be some icon, some JPEG, with Microsoft appear in the context. So you are doing local proximity matching. Or the BE engine, because it's more linguistic focused. So it uses it can handle pattern like cities such as, then it will match this noun phrase as the name of city. Or, Shulman has this work in last year's WWW about using this proximity span to find out the weighting of this keyword for a desired type, the entity. Okay. So I think with all this inspiration, it's time that we try to distill and build a systematic entity engine that can find out not only email, phone number, not only these abstract entities, but also object like image and so on. So that's the purpose of our work. Okay. So essentially what we are doing is this picture. Right now what we are doing is no matter what you are thinking, you issue keyword. You are trying to see what would be the good page look like. Then you get you get as your output the pages. Then you post-process that. We want to build this entity search by viewing the web as a collection of entities, where documents become the coordinate, the locations where entities appear. An entity may appear multiple times. Then your output should be a ranked list of entities. Okay? And pages become the supporting evidence of the entities. Okay, so let me do a demo here. So we quickly build out, it's been a few years, okay? Building a system isn't easy, okay? I think my student could witness that. Okay, we finally get this paper published in VLDB. So this is the first time we could really talk about the ranking algorithm if I have time. So I would like to go through 3 scenarios. One is an academic scenario where we collect about 6 computer science websites in the Midwest, where Evelyn skipped this morning about asking, okay? And then the e-commerce, we collect pages from a few e-commerce vendors. The yellow page, this is a larger corpus. So special thanks to Stanford for their offering of the 90 million pages to make the last scenario possible. But that 90 million, although it somehow enhances to do something that's more realistic, but I want to remind you, it is still only the 0.5% of the web. So if you couldn't find your name, don't be disappointed. You have to amplify the performance here by 200 times. Okay? So I want to switch to demo. So this query we ask for the customer service number of Amazon customer service. So the target entity is a phone number. And I have this ugly query language that I hope you don't look at it. Okay. So is it running? Okay. So I think network here is pretty slow. Whoa, why is it so slow? Please, okay. Let's wait a little bit. So this demo is running on 34 servers. And there is some complex timeout mechanism because we didn't have time to implement session control. So if I stop it now, I don't know what will happen next. Can I stop it now? Okay, let me stop it. Okay, let's run again. Maybe this. Let me first try the network. Okay, so. Maybe this the network's problem. Okay, now it looks okay. Let's try here. Is he still alive?
What is the 34 machines doing?
Oh, I'm wondering. What they should be doing is that they are supposed to be responsible for a partition of the corpus. Okay, so here we have 90 million pages, 2 terabytes. So each web server, is a very traditional kind of document-based partitioning, and they will be matching this pattern, finding out. This is getting interesting. Let me see. Let me do a smaller scale demo, and Tom, maybe you can check on that. Yeah. Let me do a smaller scale demo here. You understand what it is doing. So, well, this on the same machine, so it's why you need fault tolerance. So it's paradise. Is the network here or is the network at school? Okay. Would it help if I?
Can you run it on, is the machine, the local machine wired? Maybe you can use a wired machine.
Oh, do we have wired here?
No, I mean switch to
Oh, this is password. So Evelyn, do we have a different network? Oh, this one, no.
I think it's your network problem. It's working from here.
Oh, really?
Yeah.
Okay. Oh, okay. I see signal here. Okay. Do you want to try your computer here? Oh, okay.
I think you can switch to the.
Yes, yeah. Okay. Do you have Firefox here? That's another problem.
I think you are lost. I was trying all these demos over there. It was working from there.
Can you take your computer
Yeah, I
here?
can take my computer.
So I'll give you one more try. If not, then I'll invite you to look at this. Okay. Too bad. You try your first. Yeah. Too bad I have nothing to say except demo. So. Yeah, it's working here.
Yeah.
How can it be?
Yeah.
Do we have a longer cable? It's amazing.
Let me try this.
Okay.
Let me try.
Okay.
I hope my laptop has a.
Does this work? Is this input work? Okay, can you see? Can you see? Can get PT3?
Yes.
Oh, okay.
Maybe you can just use my laptop.
Okay. Okay, so it's working here. So, okay, so there was a query we wanted to run. Let's see if we'll come back. Okay, so this is what we mean by entity search. So the result is a ranked list of phone numbers, okay? And there are some debug information that you are not supposed to look at. And then a list of pages here. These are the supporting pages. Can you see this from the back? Okay, so here, you know, for instance, if I click on this is one instance where this phone number was found. And this happened to be an MIT student page who seemed to have too much time. You know, in the end, he said that in case, you know, you need, this is Amazon.com's customer service phone number. You know, it turns out that it's not easy to find out the example phone number like this. Okay, so I promise that we will do a little bit of the name from here. So phone number is hard to find. Okay, maybe the answer will still pop up. There is an AI built in. Okay, so. So I'm trying email here because email seems to be easier to find, and also it's easier to tell whether it's right or not. You could see that there is this Microsoft email address and there is this Bell Core email address. Okay, so if I change these two, maybe do I spell it right? You don't have S, right? No, not this. This is not a keyboard I'm familiar with. Okay. So zero answer. Did I spell anything wrong? Oh, this should be fine. Shoumen, S-O-U-M-E-N. It should be right here. I don't know what happened. Maybe, well, it should be right.
There are two spaces after the last I.
Two spaces after where?
After the last I. So before _.
Oh, okay. This shouldn't be a problem. No, it's not that stupid. Oh, okay, it's definitely. Okay, so one problem I'm using this to show one point here is that you see there is this, well, the first one, of course, is right, but why is it right? In the first version of this system, we often found something like info@acm.org appear for every professor. Or when we do research area, we find algorithm appear with every professor. So this is one example of that. So now let me use another example. Let me use, so no more. So then what? So the email I think will work unless I still type two spaces. Okay, so this is the email here. The first one I think is right. And this often you could tell from the pages where it appears. Okay, so the idea of this entity search really is that you want to collect answers or the fine-grained information for your query from multiple pages in a holistic way. That's why you need a search engine for this. But I want to show one interesting case that if I change this to phone number, the result here is not that good. As I looked at it earlier, okay. Oh, actually it's good. Okay, so the first one I think is right. Okay, this fax number, you see your phone number? Maybe this one? Or, okay, whatever. But the point I want to show here, okay, I think maybe this one is the phone number, but it doesn't matter here. The point I want to show here is you look at the second one, and then we found a similar situation in other places. You know, why is this number? Where does it come from? And then I realized that this actually, so this is not a phone number. Do you know what this number this is? Page number, okay. Looks like, you know, this is a big proceeding. You know, that make it to the 3-digit, the 4-digit. So this again tell you one thing that entity search is different. When you search for a document, you never question whether this is a document or not. But when you search for entity, you may question whether this is a phone number or not. Okay. So this is another difference here. So let me do some more familiar queries here. Let's say, so Hector Garcia Molina, this query is, from Stanford, this corpus, so it's supposed to be able to do that. You see Hector. Okay. And I want to point out here, the third answer is also the same. We could tell it's the same, but we didn't do any merging. So isn't this the kind of the most famous problem of entity disambiguation or merging? We didn't do anything here. In fact, there are other examples that you see a phone number with or without area code. We did not merge them, but both of them are ranked high. So this is consistent from some of the recent insight from the IE or question answering community, that the redundancy of the web actually makes QA or IE easier. Because, the redundancy makes it that the answer can come from multiple places. As long as your mechanism can leverage that, you often can, without doing any sophisticated like a merging, both of them will be all right. Okay. So, let's see. So we want to find out this Arnold's, email address. So I think the email address, this one looks like right, governor@governor.ca.gov. Okay. So my student keep reminding me that we got to be ambitious. This is not just a tool for toy. Okay. It has something to do with national security. So we are going to do this query. How do you spell that? So I think if we can answer this query, the Homeland Security is going to talk to us. The query is Osama bin Laden. Okay, so let's look at the answers. The answers looks disappointing here, but some are possible. Promise Osama@osama.com. Osama bin Laden at terrorism.com. Someone can try to shoot him an email. Osama@taliban.com. So we never know what's on the web. Okay, so I say, so these are a few, I think I still have 5 minutes. Yeah, so these are a few scenarios here from this larger corpus. We can show a little bit more. That it looks like as soon as we scale up to this 0.5% of the web, we could every time find some name from the audience to do demo. Not everyone, okay. So, but we could often make a point from the names from the audience. But I think this is much more than finding phone or email, or it could be doing things. Okay, so let me do this CS demo. Okay, so suppose you are a graduate student or you just graduated from college. You want to apply graduate school. You want to do your mass marketing to write email to every professor. It collects all the email address for you. I'm showing this to make a point that you could say that you could find out Kevin Chen's email by going to his homepage. But for compiling a list like this, say the email of the whole PC list, it will take you a huge amount of time to assemble a result like this. Okay. Or you could do things like here. You could find out that maybe, let's say, research area of professors in Illinois. So I'm doing an assembly of the entities that are professor, email, and the university. So the result here should again be a ranked list of something. But this something, you see, every unit of the answer has 3 components. It's the professor name. It's the, this is still that quick, but we can use this one. The professor name, the email address, and the university. Okay, so you are searching for a tuple naturally when you search for entities. Because when you search for email, why don't you search for phone number? Okay, when you search for research area, why don't you search for university? Naturally, there is a notion of tuple there. And this is something you never would think about if you search for document. You don't go to Google and say you want to search for a pair of pages. Maybe you could, but it's not a common functionality we would need. But for entity search, we really need this. Okay, so let me do this query I wanted to do earlier about the research area. It should be there. So by doing this query, the result is a rank list of tuple like a professor name, university, and research area. So let's look for, let's say, so this is Jiawei Han. I'm doing it because he's more famous than me, so it's data mining. Okay, and if you do something like a Chen Xiangzai, it's in IR, information retrieval. Here we are just tagging the entities of research area. So let me do one last query of this smaller scale. We do database across these universities. Again, here are 6 departments. Okay, so you see this collect all professors in data management, like data mining database. Okay, in these related areas, in all these corpus. Okay, so I talk about finding PDF file. I was trying to show the demos with the scenarios I mentioned in the questions. So this is an example of finding PDF file that associate with Sigma 2006. Okay, from the result, we have not checked that, but it looks like that something looks right. How about that graduate student query? You want to find out the PowerPoint file that come from the author. So here we are simply looking for a pair of PDF and PowerPoint like this one, updates.pdf, updates icdcs03.ppt, and so on. So you can spare your weekend to do something more meaningful rather than work on your presentation. Okay, so I think the last one is the book demo. Okay, so this one is an e-commerce scenario where we collect pages from bookstore vendors. So this is a query that when you independently take a title, it's hard. Okay, and this is image. But when you have a query that you look for title before image, the assembly usually is right. You see this is a pair of Hamlet. I'm querying the titles that contain the keyword Hamlet and the book image. The scenario here is that you are looking for the different copies of Hamlet from different sites. Okay, so I think I can switch back to the talk unless you have question here. Okay, so I think I can summarize this. So the point I wanted to deliver here is that this is entity search, and it somehow is different from traditional document search in several ways. Good. So how is entity search different? So I want to contrast this with document search to motivate the need for a new ranking mechanism. And that's actually the focus of this talk that I'm not going to be able to cover. Okay, so an entity is uncertain. You never ask whether this is a document or not, but this may not be a phone number. This may be a phone number. Secondly, you match an entity by the context because often you don't know what's in the entity, what's in the phone number. Although you could constrain it to have like an area code 217, but really you are relying on the context to maybe have mentioned the name, Dan Weld or, Shulman Chakrabarty to match the entity. So it's by context. Third, an entity will appear in many places. You find this phone number or the mention of his research area or his affiliation with university in many places. And this holistic nature has to be factored into the ranking. And otherwise, you are not really leveraging the web. I was trying to show the point that with this holistic nature redundancy, even if you don't do some traditional difficult problem like entity disambiguation or merging, it could still work well. And we have found many examples of that. Finally, you never search a pair or a triple of documents. But here, when you search for entities, they naturally form a tuple. You search for a phone number, you search for email. Okay. In fact, even if you just search for one entity like a form, you are already forming a tuple because you specify the name in keywords. You are already finding a tuple of name and the phone number. Okay. Why is this tricky? Because the association may not be truly intentional. I was showing you that when I was looking for Shulman's email, okay, that I found the second one was actually info@acm.org. Why? Because info@acm.org is naturally popular, frequent. So that's not intentional association. So because association is something you want to factor in, you have to distinguish that nature. Okay. So in the end, this is what we develop. Okay. What we dispatch is a conceptual model that detective or your graduate student is dispatched to read the whole collection, one document at a time. He is drawing the document, read it, okay, decide whether you find this tuple or not. And he has an infinite amount of memory that we call that his impression. And he will recognize that and accumulate, and then assume this process goes on and on indefinitely. Then your ranking formula should reflect his impression on what is the right answer. And your scoring model should reflect that. Okay. So in the end, this is the whole conceptual process. But in order to distinguish a true impression from the coincidence just because entities are popular, you have to contrast that with a randomized collection so that you can distinguish that this info at acm.org is there just because it's popular to begin with. So there is a final layer of validation. So in summary, it's very simple. It's just this global access. How do you draw document? And local recognition, how do you recognize whether it's there or not in the document? Finally, you validate that. Okay. So this is the ranking function derived this way. We are happy that in the end, it does have a log in the formula, make it really look like an IR formula. We are very happy for that. Okay. So I will not talk about the comparison, but the point here is that I think I will skip this. Okay. So we did the evaluation for two scenarios. One scenario is we find out the top 30 in Fortune 500 companies. And this is the accuracy that, like in the blue line here, more than 90% are found in top 10. And this one is we find out the email for most of the Sigma PC names that appear in the corpus. Some just don't appear. And again, and one point I wanted to make is that we compare with other different schemes. It looks like this entity rank is very robust. It's always number one. Others may come close, but they come close in different ways. Okay. In other words, some of the components, like the holistic nature or associative nature, may be exercised in different scenarios. Okay. So in other words, all these components are necessary. They may not be triggered or used in all scenarios, but they are all useful in some scenarios. Okay. So this is my required question. So yeah, we use this to survey. We use the Microsoft query log to understand how many queries are actually department store queries that are not looking for document, but actually looking for objects or entities. Okay. We actually try to derive query patterns from which we can infer that this is looking for a phone number, such as Kevin Chen phone versus Motorola phone. Okay. So we are using that. And the problem of this is that it has generally been very useful, but the query log presented how it was prepared was unclear. So we had to communicate, ask, and the evidence has been very helpful on this. We also actually connect to the dev who actually prepared the query log, has direct communication with that. Okay. And if you have unlimited access, what would you do? The research topic. I think in this 1 year, because of this query log, I have many more friends, okay, who just pop up asking me, can we collaborate to use your query log? So the topic will be, how do I handle my friends that just pop up? If you have this unlimited access, I would say that don't make a limited access, just make it to everyone. They will think about how to use that. Okay, so I'm running out of time. I want to thank all my students. One of them is here.
Thank you. So I did indeed forget to mention one region. But I think you forgot one slide here.
Oh, really?
Yeah. I think the next greeting is no longer how have you been searching, but how have you been finding today?
Oh, okay.
Okay. Unfortunately, I think I can. Okay, one question.
Really interesting system. So as a short question, it seems like one interesting issue here is scalability, where the types of entities are what we're scaling. So how hard is it to add in a new entity type, and is there any way you can imagine a user of the system adding a new entity type?
So great question. So two issues here. One is in terms of semantic, what entities are you going to support in this system? How will this be incorporated in a general search engine? Okay, I think query mining helps us to some extent for this question, what entities are popular. But there needs to be high-level thinking here, because now we are getting into type-aware system, entity-aware. This is giving us precision, but it also has its, evil, nature here about usability. So how do I figure out, how do I dispatch the entities that user wants automatically? I imagine there will be some front end in the current search architecture to do this entity, detection and dispatching. I think this is not impossible. I saw the demo from AdSense, from AdLab today. Very much is on this line of understanding the intention of query. Second issue is about performance. I think to make this really usable, I'm imagining a two-way system where a user can come here saying, I am interested in an entity called database professors, or U.S. politicians. I give you a list of names. I want to do mining about how politicians associate with Bush or Clinton. So here we will need a two-way system that can do online tagging. That's using the index to tag entities, make it to be available maybe in a few seconds, maybe in 1 minute. I can continue to ask a query with an entity called the U.S. politician.
Thank you.
Thank you.